Solve the equation. The square root of the quantity x plus 4 minus the square root of the quantity 1 minus x is equal to -1. To solve this equation, we need to isolate one of the radical expressions on one side of the equation. To do that, we'll add the square root of 1 minus x to both sides of the equation. So we have the square root of x plus 4 is equal to the square root of 1 minus x minus 1. Now we'll square both sides of the equation. Once we square both sides, we have x plus 4 is equal to 1 minus x minus 2 times the square root of 1 minus x plus 1. Simplifying the right side, we have x plus 4 is equal to 2 minus x minus 2 times the square root of 1 minus x. Our equation still contains a radical, and so we need to isolate that radical on one side of the equation. So we're going to subtract 2 and add x to both sides of the equation. We have 2x plus 2 is equal to -2 times the square root of 1 minus x. Now we'll divide both sides of the equation by 2. When we do that, we have x plus 1 is equal to negative of the square root of 1 minus x. We'll now make room to continue solving the equation. We've isolated the remaining radical expression on the right side of the equation, and so we'll square both sides of the equation yet again. When we do that, we have x squared plus 2x plus 1 is equal to 1 minus x. Now we'll write the equation in standard form in order to solve. So we add x and subtract 1 from both sides of the equation. We have x squared plus 3x is equal to 0. Factoring the greatest common factor from the left side, we have x times x plus 3 is equal to 0. So by the zero factor property, we know that x equals 0 or x plus 3 equals 0. And thus x equals 0 or x equals -3. Now we need to check each of these proposed solutions in the original equation. So we have x equals 0 and x equals -3. Checking x equals 0 in the original equation, we have the square root of 0 plus 4 minus the square root of 1 minus 0, and we're checking to see if that is equal to -1. The square root of 0 plus 4 is the square root of 4, minus the square root of 1 minus 0 is minus the square root of 1, and the right side of the equation is still -1. The square root of 4 is 2, and the square root of 1 is 1. So on the left side, we have 2 minus 1, and we are checking that that is equal to -1. 2 minus 1 is 1, so we have 1 equals -1, which is false. Thus, x equals 0 is not a solution to the original equation. Now let's check x equals -3. Substituting -3 for x, we have the square root of -3 plus 4 minus the square root of 1 minus -3, and we're checking to see if that is equal to -1. The square root of -3 plus 4 is the square root of 1 minus the square root of 1 minus -3 is minus the square root of 4. And the right side is still -1. The square root of 1 is 1. The square root of 4 is 2. And so we have 1 minus 2 on the left side and -1 on the right side. 1 minus 2 is -1. So we have -1 equals -1, which is true. And thus, the solution x equals -3 does check. It satisfies the original equation. And so the solution set to the original equation is the set containing -3.